All right, things keep following me home. And this one is interesting. It has a General Electric capital equipment sticker on it. It has a General Electric NBS, National Bureau of Standards, no I in there, NTSB? Anyway, there's no extra letter in there. National Bureau of Standards, traceability. Cal date was kind of scratched up there, but the due date is 1984. So it was due, calibration was due in 1984. I don't think it's out of Cal. Anyway, Oakland, California. Interesting. So, General Electric in Oakland. I don't know. Not sure what that's all about. And then, looks like maybe somebody else got a hold of it here. The Electronic Arrays Incorporated property number. So, another asset sticker. I don't know. Maybe these stickers are just the Cal Lab. And this is the company who owned it? I'm not sure. And I don't know who they are. Electronic Arrays. Yeah, don't know who they are. Okay, enough talking. Let's see if I can't move it around and we can. It's amazing that the bail is still intact on this thing. Those usually get broken. All right, and another property tag on the front here. Different number too. Interesting. This asset tag was 2479, and this asset tag was 3440, but the same company. So I don't know. Maybe every once in a while they go around to do asset inventory, and they just stick on a new sticker and they just check it off their list. A lot of times they'll do things like that. Anyway, it is a Keithley meter. I love Keithley. It is a 160B digital multimeter. You're thinking, why did you bring home one of those old multimeters? They're like 3 digits and they're just awful. And why do you want such a thing, right? And it's because of this. Look at this range here. Nanoamps. Yeah, does your multimeter have a nanoamp range in it? I don't think so. In fact, there's 2 nanoamp ranges. 2 nanoamp ranges. 2 microamp ranges. No, 2 nanoamp ranges, 3 microamp ranges, 4 milliamp ranges, 3 ohm ranges, 3 kilo ohm ranges, 3 mega ohm ranges. Yeah, does yours have that? 3 millivolt ranges and 4 volt ranges. Now, I bought this at, I was at Anchor Electronics the other day buying some components. I was buying the capacitors for my oscilloscope I'm trying to fix. And they had this on the shelf. It was $29. It says, needs TLC and calibration. I figured, perfect. It's the kind of thing I want to have. Let's see, the line, charge, and batteries. Oh, it's rechargeable too. Wow. I wonder if there's batteries in this thing. Should we turn it on instead of ripping it apart? I think we should turn it on. Let's look at the back. Is that going to focus? Yeah. Analog output. And then it's a voltage thing set up here. It's set up for 190 to 110. There's one for 105 to 125. I think that'd be a better range, wouldn't you? Yeah, that'd be a better range. Let's change the range before we even turn it on. I think this is a better range. Flip these 2 switches over. No, flip those this way. There, that one. That one stays, and this one goes over. Yeah, 105 to 125. Yeah, that's a much better range. We'll do that. Yeah, we'll do it. Probably off camera wasn't us. Just flipping. I flipped this little switch over. It was here that says 90 to 110, and I flipped it over here that's 105 to 125, which is a better range for where I live. All right, and it's got a permanently attached power cord, so I don't know why you have a battery in it if you have a power cord that's permanently attached, but I don't know. Maybe, oh, look at that stuff on the back. On the bottom, I mean. Oh, this is great. Let's look at the bottom. Oh, cool. Looks like the warranty is voided. Okay. To measure DC current, nanoamps, 10 nanoamps full scale. Awesome. Wow. Yeah, 10 nanoamps and 100 nanoamp ranges. 1 microamp, 10 microamps, and 100 microamp ranges. I think. Microamp, there were, 3 ranges. Milliamps, there were 4 ranges. 110, I don't know. 1 milliamp up to 100, up to 1,000 milliamps. So it must be 110, 100, and 1,000. 1,000 megohm input. Nice! 1,000 megohm range. This thing is awesome. 1,000 megohms. Awesome. I love it. All right, let's turn this thing on and see if it does anything at all. And then we'll take a look inside. All right, trying to get the glare off this thing. All right, let's turn the line on. It gives us LEDs. It gives us LEDs, volts. All right, let's, should we put some volts in it? Let's see, let me steal something here so I can, low, high. Nice. Let's put some volts into it. See if it does anything. 3.9 minus 3.9 high. Oh, that's plugged in backwards. Well, that's not good. It measures 2 volts in that direction, and it measures minus 3.9 in this direction. So yeah, it is out of cal. Definitely out of cal. All right, so, but it does something. I mean, that's encouraging, right? That's encouraging. And so we're putting in 2.68. That's not bad. It's not bad. Yeah, it's over range there. 2.68, and how about in the reverse direction? Minus 7. Yeah, it needs cal. Definitely needs cal. Okay, let's try some resistors. Let's do some ohmage. Let me get some ohms out here. Got my little test board here with some ohms on it. Let's click it on here. Megohms, k-ohms. Let's see, what am I on? I'm on something, I don't know. Ohmage might be broken. Ohmage might be broken. 100, I'm putting 100 ohms in. Yeah, ohms aren't working. Oh. Yeah, I don't think ohms are working. Okay. Ohms aren't working. How about, let's see here, let's do 10 megohms. Yeah. It ain't working. That ain't working. Okay, how about milliamps? Let's, oh, wait a minute. Oh, I'm an idiot. I had the wrong test leads active. Oh, rookie. He's a rookie. All right, let's go 100 ohms here. Oh, there we go. 100.3 ohms. Well, that's pretty good. Let's see here. Let's go, I think this is 10K? Well, I think it needs work. That's 10K. Yeah, it's having a hard time with that one. Let's try 10 megohms. 10 megohms. Oh, there we go. It's trying. It's really trying. 9.9 megohms. Not bad. Okay. All right. Now we can try, well, let's leave that 10 megohm resistor in series, and let's measure some amperage. 10 ohms at 2 volts would be 2 microamps? Yeah, 2 microamps, right? 0.26 microamps. Oh yeah, 0.26 says it's 10 megohms, not 1 megohm. Okay. Does the nanoamp, yeah, it's a little bit big for the nanoamp. Let me lower my voltage down. Okay, I've got 0.3 volts going in. I've got 22 nanoamps. Yeah, it's overranging there. And it should be 32 nanoamps. It's measuring 20 nanoamps. Okay, well, like I say, needs TLC. But it does seem to be somewhat functional. Maybe it needs some deoxit. Maybe it needs some calibration. Maybe it needs some capacitors. But I think, is it charging? Is there a battery? Nah, I don't think there's a battery. All right, let's look inside. All right, flathead screws. Definitely vintage. Whoa. All right. Oh, there we go. Oh, I'm losing my screws on the ground. Not good, not good. Find that one later. Here is the, that's an interesting thing there. All right, let's see here. Let's take the bail out and let's flip it over. Some things are falling out. Oh, those knobs, what are those? Oh, those are standoffs. Those fell out. And that's not good there. Let's put it over on the side. All right, I'm going to take a picture before I do anything so I remember how it comes back in. That's how the power cord connects. And that's how the terminals on the back connect, okay? All right, so now I can disconnect this. And I can disconnect this. There we go. And rearrange things here. All right, let me bring you guys in. All right, awesome goodness. Look at that switch assembly, and it's all on little headers. That's kind of cool. Really old school transistors, black blobby ones. Cool. Looks like that's the chip that does everything. Let's see here. What do we got going on here? This is kind of weird. What is this part? An SL35155. F Fairchild? What is going on here? Wow. Something's missing here. Let's turn it around. Not too many adjustments inside. Not too many. Let's see, that's a transistor. This must be the electrometer. Must be the fancy bit. I'm kind of surprised that there's no Teflon standoffs in this thing. It's all PC board. The input is back here and it comes in, and there are 4 transistors here. Yeah, Yeah, there's really not a lot going on in this thing. It's kind of strange. I'm really curious about looking at the schematic of this thing. A lot of nice capacitors over here. Old school power supply. Yeah, I'm fascinated by this thing now. There's no fancy ceramic resistance thing. Resistors on ceramic substrate and stuff that had all the ranges and stuff on it. It only has 1, 2, 3, 4, 5, 6, 7 adjustments. That's not a lot. Not a lot. All right, let's fused on both sides. That's kind of nice. Or fused just in two places. I don't know. It's kind of weird. All right, let me do a perusing here, and we'll get out the schematic and see what this thing does. But I'll give you a tour here. All right. That's for the front panel. This is where the input is. It's pretty healthy 5-watt resistors there. 0.1% resistors. Very nice. Yeah, see, these are, instead of doing it all on one unit, they just have a whole bunch of expensive 1% resistors in here. 0.1% resistors. I'm not sure what the spec. There was a spec on this on the bottom. I didn't read what the spec was for percentage. Let me take a quick look at that. Let me take a quick look. Where's my bottom? I've lost my bottom. There it is. Yeah, this unit should be about 0.2, 0.3% accurate, so those must be 0.1% resistors. Some test points here, 5-volt, 0, some capacitors that maybe we could replace. All right, get you on the tour here. It's very old school. I love old school because I'm old. Oh, there's a plus 12-volt test. A 1-volt test. So where's the Zener? Where's the voltage reference in this thing? I don't see that either. All these dipped tantalums always makes you nervous. Makes you nervous. All right, I've replaced these two capacitors because I could. And so we'll just measure some voltages here. This test point's labeled minus 12. And we'll turn the machine on. The hand's going to be in the way. All right, there we go. Turn the machine on. And we are measuring minus 11.55. Can you see that? Minus 11.55, fine. I'll go over here to the plus 5 section. And we're measuring, yikes, 5.9. I think we're going to turn that off. 5.9. That seems high to me. And there's a 5-volt regulator, but it looks very odd. I'll show a picture of it here. These are some of the most original 5-volt regulators I've ever seen. They're not in the TO220 package. No, these are super old. The minus 12 is going through a 7912, and it seems to be operating just fine, but this 5-volt regulator is measuring way too high. And it's going into, 5-volt logic. It's going into 7404s and stuff. So I'm going to swap that out. I just don't like that high voltage. Long-term reliability, if nothing else. I just don't want to have that almost 6 volts running around. So let's get rid of him. He's over here on this heatsink. So I'm going to pull him out and put in a new 05. So I pulled it out of the board. You can see here on the heatsink. But see its size compared to a regular TO220. It's I don't know. It's like 20% bigger. So yeah, let's get him out of there. And no heatsink go. But yeah, look at the size of that beast. He's big. All right. Let's I've got one that's been recycled here. It's still got a little bit of PC board on him. He's a beauty. He's a Motorola, I think. Yeah, Motorola. So vintage as well, but a really good one. Let's see, is this going to get in the way if I go this way? I don't think so. People usually put on too much of this stuff. Sometimes when I'm in the mood, I put too much on. But I think for this one, that's good enough. 5.09. Wow. It is it's a Motorola Part 2. It's not a 7806. It's a 7805C, 1976. Does this one have a date on it? 1988 or something like that, probably. I don't know. There we go. Here's a replacement. Let's get him onto the board. The kills. Stay there while I get. Oh dear. Nope. I need a bigger bench. Oh, while we're here, this thing on the bottom here is underneath this one op amp, and it is basically like a Teflon ring to seal that off, so you don't have any strange currents or temperature or anything on that thing. So he's the special one. All of the magic happens on that one. And Q102. We'll have to look at him later. All right, so we have our 5-volt regulator back on the board. Let's see if it's regulating 5 volts. Put this back on. There we go. You may have noticed my new voltmeter. I'll have to do a video on that. Picked it up used on eBay. Let's see here. This is ground, and this is +5. Oops. +5. Turn him on. Beep. And we're not plugged in anymore because I'm safety conscious. Let's plug him back in. Okay. I like that better. 4.99. Much better. I'm much happier with that. much happier with that. So let's go stop there.